last section of Chapter 7 deals with scale models or scale drawings. And I know you've done this stuff before, so for the most part this is quite a bit of review, but we'll have a couple more just slightly challenging questions than you had previously a few years back. So first of all, just to review a scale model. It's an object or drawing with lengths proportional, so guess what, we're going to be setting up a lot of proportions here, to the object it represents. And when I think of scale models, a couple things I think of are like model cars, right? You can put together little model cars that represent what an actual car is in real life. Same thing, architects, engineers, they make models, whether it's a drawing or an actual little pieces like this little house right here. Okay, they make the size lengths proportional to what it's supposed to look like in real life. So you can actually see what it should look like in real life, just a smaller version of it. So side lengths are always proportional when dealing with scale models. So let's go ahead and use that. First things first, the scale. A scale is the ratio of a length on the model to the actual length of the object. And when I think of scales, I always think of maps. I always think of maps because maps usually always contain a scale on it. And for example, here would be my scale. Every 0.4 inches on this map is actually 40 miles in real life. That's what that scale represents. So 0.4 inches on the map represents 40 miles in real life. So that'd be my scale. That'd be my scale. And let's say I actually wanted to find what the distance was between two towns. For example, let's say I want to find the distance between Memphis and Nashville. Well, I would take a ruler and I'd be measuring in inches. So I'd put 0 at Memphis, and it looks like we're about right here. Oops. Oops. Right there, which is about 3.5 inches. So this is how I'd set it up. We just said that side lengths are proportional. Okay. What I always like to do is I like to put the model or the drawing on top and the actual distance on bottom when I set up my proportion. Okay. And the first ratio you set up is always the scale. I always use the scale as my first ratio. Well, it gives you the scale right here. 0.4 inches over 40 miles, right? So model on top, okay, 0.4 inches, actual on bottom, so in real life it's 40 miles. And then we set that equal, well, what are we trying to find? From Memphis to Nashville. So we just said on the map, it's 3.5 inches, and in real life, we don't know. And that's what we're trying to find. So we just go ahead, grab our calculator, 3.5 times 40, take our cross product, and we get 140. And we set that equal to 0.4x. And I'm going to bring that over here. 0.4x. So to solve for x, we divide by 0.4. And 140 divided by 0.4. X equals 350. And always have a label. Well, 350, this is in real life, miles. And that should make sense. That should make sense, right? If I get some crazy answer like 3,000 miles, well, 3,000 miles in one state. And 3,000 would cover the whole United States. So just think about, it should make sense. If it doesn't, you probably set up your proportion wrong. Well, you may not actually get a map. It might just give you it right into the words. So for example, the distance between Boston and Chicago on a map is 9 inches. If the scale of the map is 1 inch to 95 miles, so every 1 inch on the map is 95 miles in real life, what is the actual distance from Boston to Chicago? Well, it's the exact same thing. Your first ratio, you always start with the scale. So, and we said put the model on top and the actual on bottom. So the model is 1 inch, is 95 miles, and then we want to set that equal to, well, what are we given? We're given the map's distance. So the model's on top, the map's on top, and we're trying to find it in real life. So almost the exact same thing here. So 1 times x is just x, and 9 times 95 is 5. Carry the 4. And we got 855, so x equals 855. Well, what is my distance in real life? Looks like miles. So 855 miles. Okay, nothing too crazy. All right, let's do just a little bit something different here. It says a miniature replica of a fighter jet is 4 inches long. The actual length of the jet is 12.8 yards long. First question says, what is the scale of the model? So remember, if I look back to this last scale, we had 1 inch is 95 miles. And the scale before that, we had 0.4 inches is 40 miles. Well, usually we like to say like 1 of something is equal to whatever else. Like 1 inch is this many yards, or 1 centimeter is this many miles. So if I look at my scale, right now it's every 4 inches is 12.8 yards. So I could use that every 4 inches equals 12.8 yards. But we don't really like that. We like to say for every 1. I know that first example was 0.4. It's probably because it's a little smaller map. Let's go to like, what does 1 inch represent? Well, to figure that out, I just divide by 4. Divide by 4. So 1 inch represents how many yards in real life? Well, 3.2 yards when I divide by 4. So there would be my scale. For every inch, it's 3.2 yards. It just sounds nicer, right? For every inch, it's this many yards or this many miles, depending on what you're talking about. So let's get it for every 1, whatever your map or your model is. And remember, your model always comes first. Here's the model equals the actual when you do your scale. Oops, I wish I could spell. Should be a C there. Ugly looking C. Last thing is, this is new. How many times as long as the model is the actual jet? So how many times bigger is the jet than the model? Well, right now we know that 1 inch is for every 3.2 yards. So it's not 3.2 times bigger. Okay, I can't tell how much bigger something is if I have different units. And right now I have different units. So if I want to figure out how many times bigger something is, so how many times as long and how many times bigger or smaller, I need the same units. So for example here, I need to convert yards into inches. And one way to do that is just like our dimensional analysis that you did last year. So let's convert yards into inches. So we want to cancel yards, so yards has to be on top. Well, some of you might be able to convert how many inches are in a yard, but let's just start with feet, because we all know that there's 3 feet in 1 yard. And then lastly, we want to cancel feet now, since we already canceled our yards. And so to cancel feet has to go on top, inches on bottom. Well, there's 12 inches in 1 foot. So now our feet cancel. Now we have inches over inches, so this will tell you how many times bigger it is. Really, I could have just converted the 3.2, multiplied by 3, multiplied by 12, and you figure out just as well. But 1 over, well, 3.2 times 3 times 12 gives us 115.2. And if you notice, the inches actually cancel each other as well. So we would say like the scale factor is 1 to 115.2, or in this case, it's 115.2 times bigger. 115.2 times bigger. So you don't actually have to do it the dimensional analysis way. A lot of you probably would have just said, well, convert yards to feet, so multiply by 3, convert feet to inches, multiply by 12, and that's how many times bigger. That would work just as well. I like to have it nice and neat so I can see everything that's going on. So I do that dimensional analysis. There you go. That's all there is to it. So 6 through 18 even, skip 12, and then do 26 through 29 as well.